All right, section 2.2 is going to be about alkanes, alkyl groups, and isomers. All right, alkanes, they're not considered a family, but they are a group of compounds that technically don't have a functional group. When we talked about functional groups last section, we talked about a group of atoms that gave the chemical and the physical behavior of the compound. That usually include either double bonds of some sort or an oxygen, or pretty much anything that did not deal with carbon or hydrogen other than a double bond or triple bond. Well, alkanes technically are not, again, is not a particular family. Alkanes is where you have all CC single bonds. All right, so it is, some people don't classify as a family, but it is a family of compounds that they have their own characteristic properties. They're not much. They basically, if you ignite them with oxygen and heat, they will pretty much explode. That's basically all they do. They don't really do much. So some people don't call them technically a functional group, but they are a class of compounds. So alkanes, example, the simplest alkane is methane, where you have one carbon and the 4 possible hydrogens. Anytime you have C single bonds, so you can also have branching groups. So you have the maximum number of bonds on your molecule. You don't have a double bond, you don't have a triple bond, you don't have any oxygens. It's just carbons and hydrogens, and everything is a single bond. Okay, so these are basically examples of alkanes. Another way of talking about these is what's called saturated hydrocarbons. All right, a hydrocarbon is anything that has hydrogen and carbons in it. That's the name, hydrocarbons. Very simple. Saturated means pretty much all single bonds with maximum number of hydrogens on all the carbons. All right, the saturated implies it's saturated with the maximum amount of hydrogens. So pretty much, again, same thing, single, or everything is a single bond. Another word people use is aliphatic. Aliphatic comes from the Greek word of fat, but pretty much it means only hydrogens and carbons. Hydrogens and carbons. Okay, that's basically what aliphatic means. Okay, there is a simple formula for straight-chain molecules. This is only for straight-chain, non-cyclical molecules. Non-cyclical. For straight-chain molecules, the formula is CnH2n plus 2. So from this formula, you can figure out how many hydrogens that molecule should have, knowing how many carbons it has. So if I have a molecule that has 5 carbons on it, what's the maximum number of hydrogens that could be on there? That would be 12. All right, because you take 2 times 5, which is your number of carbons, plus 2, you get 12. So for a straight chain molecule that has 5 carbons, 1, 2, 3, 4, 5, the maximum hydrogens that you can have is 12. And this is just for straight chains. If you have a cyclical compound, this will not work. This formula does not work. Okay, so if you count, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So, other ways of drawing these molecules, what you might find is that you can see it takes me a long time to draw the carbon, drawing out all of these hydrogens like this. All right, it takes a long time to do this. There are shorthand ways of drawing these structures. All right, so let me kind of go over the shorthand so that we don't keep, like I take time in writing these molecules. Another form of doing this is drawing it CH3 CH2, CH3. It's a lot quicker. I don't have to draw all the bonds between the carbons and hydrogens. It's implying that you have a carbon with 3 hydrogens on it, which is for this carbon right here, carbon with 2 hydrogens on it for this carbon, and a carbon with 3 hydrogens, which would correspond to that carbon right there. So that's how I'm going to start drawing these molecules. Even a shorter hand would just be CH3, CH2, CH3. Okay, I don't like it that much. I like having the bonds right here in between the atoms. So those are just a few ways of how I'm going to start drawing them from now on. The next thing is that you can have straight chain molecules, as I've been implying here. Straight chain, which they call normal alkanes. I'm not sure why they get the word normal. They usually put an N sometimes in front of the word. Normal alkanes. Alkane. And then you can also have branched alkanes. And we're going to talk about branched alkanes, and we're going to talk about how to name these types of compounds. Okay, so just to give you an example, let's take the formula C4H10. Okay, so 1, 2, 3, 4, and then H10, CH3, I'll put CH2, CH2, CH3. Okay, straight chain, meaning you have carbon in straight line. Okay, that is what's meant by a straight chain or the normal. A branching group would be where one of the groups is hanging off of the longer chain. So you can have a carbon. So I still have 4 carbons, but I have 3, and then I have a third one coming out over there. So that would be a branching form of it. Okay, and again, you would have the maximum number of hydrogens on it. Okay, so it's a different molecule, but the same formula. Okay, this is what is called an isomer. These are what isomers are. Okay, same formula, but a different molecule. Okay, or you can say it as a different arrangement. I think your book calls it arrangement, where the atoms are arranged in a different order. They're not 4 in a row. You've got 3 in a row and then something branching off of it. Okay, so those are the types of alkanes that you will see throughout this class. You have the straight chain and you have the branching chain, and these are what's called isomers. In particular, these are called constitutional isomers. We're going to learn a lot of different types of isomers, but these particular example I gave you is what's called a constitutional isomer, where you have the same formula, but the arrangement of the atoms are in a different place. Okay? So that's what isomers are. And just to kind of give you an idea, let's do a problem. Let's do a practice problem. All right, now just to remind you, in class I talked about that we'll be doing problems in your notes, and these are the types of mini quizzes that I might give you in class just to see if you're watching all the videos. I might say in chapter 2.2 we had a problem about drawing different isomers. Can you either tell me the problem, or I'll give you a different problem and you have to know obviously what that means. Okay, so let me give you a formula here, C5H8O. So 5 carbons, 8 hydrogens, and an oxygen. See how many different isomers you can draw. Try to draw at least 3 to 5. All right, I'm going to tell you right now. Well, I'll tell you when we get back. I'll keep you in suspense. All right, so to let you know, there is probably over 30 to 50 possible structures for this formula, and they are all a different type of isomer. Okay, I'm going to just draw a few of them. Some of the common ones that most people draw, I might even take up this whole page just to draw structures. I don't want to take up too much time doing this because I think you'll kind of get the point. But here's one possible compound. Okay, I'm actually drawing another type of shorthand that I forgot to talk about. this is a line drawing, so let me talk about it as we're talking about it here. Line drawings are even a quicker way of drawing molecules, and how line drawings work is every time that you see an end, so a point here and that point right there, those are carbons with the maximum number of hydrogens on them, as well as here, here, and there. Every time that you see a point or an end, that is a carbon with maximum number of hydrogens. So here's a carbon. Okay, remember carbon makes 4 bonds. It's currently making 1 bond to carbon over here. So what does that mean? That means there are 3 other hydrogens attached to it. So that's technically a CH3 group. I'm going to draw them out with the actual atoms. And that carbon is attached to another carbon right here that is double bonded to another carbon. So what's the maximum number of hydrogen on there? That would be 1 hydrogen. So it's implying that this carbon right here has 1 hydrogen. And then this carbon is bonded to another carbon. So that means there's a hydrogen on there. This carbon right here at the carbonyl, all right, how many hydrogens are going to be on there? The answer is 0, because this carbon is currently making 4 bonds. 1, 2, 3, 4. And then this carbon right here, all right, that carbon right there is going to have another 3 hydrogens. Okay, so this shorthand way of drawing molecules makes things even go a lot quicker. Sometimes it takes a little time in order to understand what it is, but just to let you know, these are the same molecules. All right, this is where I have all the hydrogens in it. This is the skeletal structure, or the shorter way of drawing it, the quicker way of drawing it. Okay, I'll kind of use these interchangeably so you kind of get used to it. Okay, but sometimes it makes things go a little bit quicker, and it's easier to see your molecules. All right. Anyways, going back to the isomers, another isomer would be, instead of having the double bond between these 2 carbons, having them be between those 2 carbons. That is a different molecule, but it has the same formula. Okay? So that would be a different isomer. Another isomer is where the carbonyl is maybe at this position instead. Okay? Or the carbonyl is at the end, but your double bond is in the same place. So it would be right there, and you would have a hydrogen there. That's another isomer. Having the double bond in that position is another isomer. 1, 2, 3, 4, 5. Okay. Another possibility is the double bond even closer to the double bond. To the carbonyl. That is another isomer. All right, so you can start seeing there are a lot of different isomers. Okay, that's just a few. Hopefully you got some of those. Other possibilities are, instead of having 4 in a row, you have a branching group. This is now where branching groups start coming in. Maybe something like that. That is another possibility. Okay, let's see what else I can think of here. We can think of, that's an aldehyde, let's think of a ketone, like that. That would be another possibility. Other ones are maybe 2 double bonds, and let's see, 1, 2, 3, 4, 5, and an alcohol. That would be a possibility. Another one would be, now if you don't believe me, all right, go back and check to make sure the formulas are correct. All right, so on this molecule I have 1, 2, 3, 4, 5 carbons. As far as hydrogens, remember it's the maximum number. So there's 2 hydrogens here, there's 1 here, there's 1 here, 1 here, 1 here, and 2 there. So that's 2, 3, 4, 5, 6, 7, 8. H8, and there's 1 oxygen. So notice it's still the same formula, but this is an alcohol. All right, these over here, that's a ketone, that's a ketone, that's an aldehyde. All right, that's a ketone, that's an alcohol, but the alcohol's in the middle. These are all different molecules. All right, now let's make it even more interesting, is that you can even have cyclical compounds and the formula is still the same. Okay, so 1, 2, 3, 4, 5 carbons. So that's C5. How many hydrogens? There's 2 here, 2 here, 2 here, and 2 here, for a total of 8. How many oxygens? 1. Notice, all the same formula, but the structure is different.